All right, so 7.2, multiplying, dividing rational expressions. Um, One thing with these, you are going to be multiplying and dividing. We already know how to multiply and divide fractions. Um, and then you're going to be simplifying. It's same thing kind of as 7.1 as far as the simplifying these denominators and numerators. So I mean, there's just a lot of examples to do, but there's not a whole lot of like new material that we have to cover. And then there's a lot of different ways you can kind of solve these problems. So you just kind of got to look for, what are some of the shortcuts. What I always kind of want to start out with is with our coefficients, with our numbers, more so than the uh, variables. So what we have is a 15 on our top part in our numerators, and then we have 3 and 5, and we're multiplying, all right? So hopefully you understand that 3 times 5 would be 15. So really you're going to have 15 and 15. They're going to actually cancel each other out. So let's say you didn't see that, but you see like 15 and 5. Well, 5 can go into 15 3 times, and this would be 1. And then you would say, oh, well, 3 over 3, the 3's would cancel. Either way, our numbers, as far as this problem go, are going to be gone. All right, then we kind of work with our variables. So all that's left in our denominator would be x over 4. But on the top, we have x times x over 7. Okay, so that would make this, again, same base. We add 1 and 7 together, and we get x to the 8. So we got x to the 8 divided by x to the 4. Remember the rule, bases are the same. Just subtract top from the bottom. 8 take away 4 would give us x to the 4. All right, so that's kind of like the basic type of problem that you're going to see with 7.2. Get into a little more complex problems. So it's kind of similar to 7.1 in the sense, in this type of problem, we would want to simplify these things. But again, they're going to be, when they're multiplying, when you multiply, you just go straight across, right? But before we kind of do that, let's simplify these two situations here. So we're going to have x times, what am I going to do on here? What can I factor out? X squared minus 3x. So I want to pull out an x, and that's going to give me x minus 3. All right, so we come to this problem here, 7x minus 21. I could factor out a 7. Again, that's going to give me x minus 3. And again, I'm going to have this times 9 also from this other. So we're doing this fraction times this fraction. So now look what can cancel out. The x minus 3's are going to cancel each other out. And at this point, we just kind of reset the problem because there's nothing else that can cancel out between my numerator and denominator. X times x will give me x squared. 7 times 9 gives me 63. So you just kind of have to work through these problems, look to see what can I cancel out. They're all going to have something that can cancel out. So once you factor it, you're looking for those things that I can cancel out. And we'll talk about kind of what happens when you're dividing, because remember, dividing is just multiplying inverses. All right, so let's look at this example here. We're still multiplying. So I'm just going to factor this, and I'm going to kind of write these two as on the same denominator. This is a factor of 2 squares, so this would be x plus 7, x minus 7. And then, like I said, I'm just sliding that x plus 5, and I'm going to write it in parentheses. Over, now I got to factor this. It's an easy, there's not an a value, so it's two numbers multiplied to give me 35, add together give me 2x, so this would be x minus 7, x plus 5. Then I have this x that's kind of hanging out from this fraction here. So just look to see, I have, however you start, but x plus 7, I don't have an x plus 7 on my denominator, so I can't cancel that. My x minus 7s, they're going to cancel out. And my x plus 5s are going to cancel out. And when I do that, I'm going to be left with just the x plus 7 on the top. And that x didn't get canceled out, so I have that x on the bottom. Have some more room on number 4. All right, so what you're going to see on this example here is trinomial over a trinomial being multiplied by a trinomial over a trinomial. And you'll look at that and you'll get a little freaked out. But we know how to factor trinomials. The problem is we have to do it 4 times. Okay, each of those trinomials will factor into 2 binomials. What is nice, we don't have a values there, so they didn't really make it too crazy for you. But we just got to factor them all. Once as I factor them, I'm going to write them all together on my numerator and all together on my denominator. So let's start. Y squared plus 9y plus 18. That factors to y plus 6 times y plus 3. I'm going to stay on my numerator. I'm going to come over here to this, y squared plus 2y minus 8. And that will factor to y plus 4, y minus 2. And then we're going to come now work to our denominator. Y squared plus 8y minus 20. All right, so for negative 20, that adds together to give me 8 would be y plus 10, y minus 2. So 10 times 2 would give me negative 20. 10 plus negative 2 would give me the positive 8. And then the last one, y squared plus 6y plus 9. That is actually going to be y plus 3 times y plus 3. So again, I took each of these trinomials and factored them into their binomial forms. And now I'm going to cancel out. Whatever is the same is going to cancel out. Now just be careful. Now look, see this y plus 3? It is not going to cancel both y plus 3s. It can only cancel one y plus 3 out. All right, so there will remain another y plus 3. There's not a y plus 4 that will cancel. These y's minus 2, they're the same. They're going to cancel out as well. And then once you do that, what are you left with? You're left with y plus 6 times y plus 4 over y plus 10 over one of those y plus 3s. So that would be your answer. Those other things are not going to factor themselves out. So I almost feel like that's probably the toughest type of problem you'll see. But again, they're all a little new, so it's going to require, being pretty decent with these factoring stuff. All right, so let's get into some division problems, and depends how good you want to be with your notes. But again, when I'm doing these and I'm writing them down, I'm going to write the original problem down. But if I'm just doing these just to get the answer, I wouldn't write it in this form, okay? So I would write it in multiplication form. In other words, if this showed up on my screen, I would write 3z to the third over 2z to the fifth, but I would change that. This is where I would just change this to multiplication and then do the inverse, okay? So in other words, I gotta flip these around. So I'm gonna put the 4z to the fourth on top and the 9z on the bottom, because that's the only difference with division, right? You change it to multiplication and you do the inverse. And now it's just like the other problems we were doing. All right, so we can multiply 3 times 4 and get 12 and add these z's together. Okay, we'll deal with the z's, but when I'm dealing with these coefficients, with these numbers, I'm looking to see what I can cancel out. Okay, in their current state, we have 3 and 9, right? That can reduce, and 2 and 4. 3 would go 3 would go into both of these, 3 would go in there once, and 3 would go into the 9 3 times. And then with the 2s, 2 would go into 2 one time, and 2 would go into 4 2 times. So we're kind of simplifying our numerators first. Now I'm going to just rewrite these fractions. So 1 times 2 would give me 2. And then how many z's am I going to have on the top? I got 3 here and 4 here. I'm multiplying. So the rule is to add the exponents. 3 plus 4 would give me 7. So I got 2z to the 7th there. Let's work on our denominator now. 1 times 3 would give me 3. And how many z's? I have 5 here and 1 here. So 5 plus 1 would give me 6. Okay, well, my 2/3 is reduced. That's going to stay there. But these bases are the same, and I'm dividing. So the rule when you're dividing, keep the base. Subtract top from the bottom. 7 take away 6 is just 1. And I really don't need that 1 there, so it would just be 2z over 3 would be my answer there. All right, get an example. X minus 2, x plus 8 over 6x to the 6. And again, it's division. I'm going to write it the way they first appeared. All right, so we know we got to change that to multiplication, do the inverse, 18x over 7. And what I'm going to do here is I'm going to factor out that 3. Okay, so I'm going to save a step there. I knew I had I know I can factor on this one. These other ones were already actually factored for us. X plus 2, x plus 8, 6x, 6. So we could multiply these kind of together. What you're going to see here, again, it's 18 on the top and 6 and 3 on the bottom. All right, what is 6 times 3? It's 18, right? So the 6 and 3, really, they're going to cancel out, and the 18 is going to cancel out. That would save you a step there. I want to see if I messed something up. Oh, this was x minus 2, and I wrote this should be x minus 2 here. Okay, because I was thinking these x minus 2s are going to cancel. Somehow I switched it to a positive, but it should stay, it should remain negative. So the x minus 2s cancel each other out. So, well, we could just deal with these we have x over 7 divided by x over 6. Remember, the rule is top minus the bottom, so it's 7 minus 6. So I'm going to have an x left on top. So what I'm going to have is x left on top from here, from these two. 7 take away 6 gives me that x. So these are done. And then I'm left with that x plus 8. And that's all there is there. That's all that's left. Let me get a little more room for a few more examples. All right, so this is, again, how the problem was presented. One thing I want you to kind of see right here is this 9 minus, like whenever they give you a problem that's kind of written, you know, like this with a number in front, I would just kind of rewrite that because I already know what they're going to do there. So I would factor out that -1 and they make it x minus 9. So remember, when you factor out a negative, it's going to switch all the signs. So the negative x becomes positive, positive 9 becomes a -9. It's kind of just a hint that you're going to have to do something with that. And I almost can guarantee that x minus 9 is going to factor out. But again, we're changing that division to multiplication. Now remember, we're going to be doing the inverse. So this denominator is actually going to be on top. And I'm just going to factor it now instead of just writing and then factoring it again. So I'm going to factor the x squared minus 19x plus 90. And I'm moving it to the top because I'm switching it from a division to a multiplication. So again, that's negative, that's positive, so I know it's going to be, they're both going to be a minus. And how do I get 90 and get 19? That would be 10 times 9. So I'm going to have x minus 10, x minus 9. Okay, now I'm going to work on my, it was my numerator here, but it's going to become my denominator here once I change this to multiplication and I flip it. So again, it's a minus here and a plus, so I know again I'm going to have minus, x minus, x minus. What will give me 60 and then add together to give me 16, the same thing, 10 and 6. And I would probably just put that x plus 4 in parentheses since all my other binomials are in parentheses. And looks what is the same that's going to cancel out. Okay, we've got x minus 9 here, x minus 9 here, they're gone. You got x minus 10s directly on top of each other, they're gone. And that's all it's going to cancel out. So I'm going to have x plus 4 and then negative 1, x minus 6. And you can leave the x plus 4 in parentheses if you like, or remove it. It'll take either one of those. All right, let's get a few more examples. We've got 3 more examples here. And again, this section, it's kind of a lot of different problems. But as far as the factoring, that really isn't new. But again, repetition with math is kind of what they're going for. You just got to keep kind of doing these over and over again. All right, so this was that fraction. Now remember that negative sign usually floats right here in the middle of the fraction. I like to just move it up to my denominator, okay? Instead of leaving it just off to the side. And I had this fraction is just being multiplied by q to the 5th. And if it makes you feel better, if you want to make that a fraction, you can put it over 1. So what am I going to have? You know, normally I like to just deal with the coefficients first. Negative 8 over 32, that's going to reduce to negative 1 over 4. We see we have p squared. They're going to cancel each other out. And we're doing q squared times q to the 5th. That's going to give me q. And again, you add the exponents. 2 plus 5 gives me 7. And I got q over 6. I'm just bringing down. And what's going to happen is same base. We're dividing. 7 take away 6. And that would give me just q to the 1. Or just q. And that's your answer, negative 1q over 4, or you could write it as negative q over 4. But that's how that one is, not a real tough one. And then 18, 2w to the 5th over 3w to the 6th. It's another division problem. So don't be real careful not to start canceling things out, even though you really can't the way this is set up. Remember, you have to change that to multiplying the inverse first. Okay, so always do that first before you really start doing anything. Because these problems, they may look one way, but once you change them to multiplication, they really look different. All right, so at this point now, I will deal with, we did a similar problem to this, but I'll deal with these coefficients. 2 and 4 is going to reduce to 1/2, 1 over 2. 9 over 3 reduces to 3. Once I do that, I can just, now I can combine the exponents. W to 5, W4 gives me 5 plus 4 would give me 9. And then on the bottom, 1 times 2 gives me 2. W, I got 6 here, 2 here, so it's going to be W8. 3 to the 2 is not going to reduce. The only thing that's going to reduce is these W's. 9 take away 8 would just give me 3W over 2. And our last example So another division. So this is another one of these problems with that weird little 5 minus x, okay, that I'm gonna kind of deal with changing that to multiplication, and I'm gonna rewrite that the way kind of I want it. So we can read, this is a factor of 2 squares. We can do that now. We're just gonna kind of wait to rewrite this into its multiplication form. So you flip, change it to multiplication and do the inverse of the fraction. At this point, well, hold off. All right, so now let's start simplifying. X minus 25 becomes x plus 5, x minus 5. And we got a 4 and an xy over here. We got 12x here. Now remember, this is that one where you're going to factor out a -1. And we're going to make this x minus 5. All right, this is the fun part. We get to cancel stuff out. X minus 5 are going to cancel. You have x's here. They're going to cancel. Let me kind of do those in red. 4 and 12. That's going to reduce to 1/3. And that's all that I'm seeing is going to cancel out. So we have that y here, that didn't get canceled out, so the y remains. The x plus 5 stayed. And then I had 3 times a -1, which would give me -3. So just be careful, especially if you're doing the way I'm doing it, that when you start canceling stuff out, that you just don't forget like the -1, the 3, the y. That's one that, might get overlooked. You kind of forget that y is there and you just write x plus 5 as the answer. So you just got to kind of work neatly, step by step, and try not to forget signs or variables within your problem. And that is 7.2, multiplying and dividing rational expressions.